So at the last class we covered Newton laws, right? Newton laws and how to apply Newton laws in usual cases. So this lesson is a extension of that, right? But first take down this topic, impulse and momentum. Impulse and momentum. Take it down. So when you get a question, please use the chat box, right? And once you finish something, thumbs up, right? Otherwise, I don't know whether you don't have any problems on that or not, right? So use thumbs up, right? Right. Under that, right? Impulse and momentum. Under that, right? Impulse. Within brackets, capital I. Impulse. The notation is capital I. Right. At the last class, we learned this one. Rate of change of momentum is unbalanced force. Okay. This is F equals ma actually. This is change of momentum. When you divide it by time, you get the rate of change of momentum. Rate of change of momentum. So that is the force. Okay. So for this lesson, I need to cross multiply this. Then it becomes Ft mv minus mu. Okay. So change of momentum is equal to Ft. Force times time. So this Ft is what we call impulse. Right? Impulse can be defined as force times time or change of momentum. Change of momentum also, another term for that is impulse. We can also find that using F times T. Right? So that is this lesson is actually a extension of F equals ma, right? Right, take this 2 down, draw a margin to this. This is what we will be using when we do problems. Thumbs up, right? If you got it. Under that, right, there are 2 cases here, right? The questions are in 2 cases. If force is constant, you can use Ft. You can just multiply force by time in order to find impulse. In order to find impulse, you can just multiply force by time. So if F varies, in order to find impulse, you have to get area of Ft graph. Take these 2 down. Take these 2. You will understand what I'm saying when we are doing questions, right? If F varies, I equals area of Ft graph. Area of Ft graph. Right. Got it, right? Then try the first question on the tute. And send me the answer in the chat box. Quickly, right? That is an easy question. First question. Send me the answer in the chat box. So what they ask is, which one has the same dimensions as impulse? Impulse, right? Not force. Impulse is not force, okay? See this equation? Impulse what? Force times time. Not force. Force should be multiplied by time. Or impulse can have same dimensions as momentum. Change of momentum. This is change of momentum. So impulse can have same dimensions as momentum. Change of momentum also has dimensions of momentum, right? So what is the dimensions of momentum? Mass times velocity. Mass times velocity. mlt minus 1. Then if you multiply force by time, let's see what we get. Force is mass times acceleration, right? ml t minus 2 times time. So this is ml t minus 1. See that? Both have the same dimensions. If you want, you can write this down. Both have same dimensions. Got it? It is not force. Rate of change of momentum means force, right? Not impulse. So you have to clearly understand the difference. So the answer should be linear momentum. See that? Got it right? Answer should be second one, okay? Got it? Right. So that's the difference. Impulse and force, two different things, right? Force times time is impulse. So there are two ways to find the impulse. One way is, if f is a constant, you can just multiply force by time. But if varies, you have to get the area, you need to get the area of ft graph. In the questions, they give an ft graph, right? So you can use that, find the area and get. Right, then try second one. Second one. Send me the answer in the chat box. It doesn't matter you got the wrong answer, right? I need to know whether you understood or not. Send me the answer for the second question. For the second one. So if you just join, take this down. We just started the class, right? Take this down, right? Try the second question. Yeah, second question, change of momentum, right? So impulse is change of momentum. Or else force times time. Right. Second one, yeah, second one. Then try third question. I'll give you a minute to try third question, then I'll explain third one. If you join just now, just take this down, right? First, if you got the answer, send me. So third one, speed gained by an object when an impulse 10 Newton second. This is not force, this is impulse, right? 10 Newton second means this is a change of momentum actually. It is given to a 2 kilogram object. You can draw a sketch like this. 2 kilogram object. So as a result of that, speed, it is initially at rest. Then its speed increases to v, velocity. So how can we use that? You just use this one. What is the equation? I equals mv minus mu. So I is given as 10. Mass is 2, velocity is, this is final velocity minus initial velocity, initial momentum. This is the final velocity, this is the initial velocity. Initial velocity is 0, right? So final velocity is just v, initial velocity is 0. So you get 0 here. Got it right? Then 2v equals 10. Then what can we say? Just divide by 2. This becomes 5 meters per second. So it gains a velocity 5 meters per second. Take it down. If all right, thumbs up, right? Otherwise, send me the right. Then try next one, fourth question. Draw a sketch, right? First draw a sketch, read the question, then draw the sketch. Try fourth question. Draw a sketch. So from a 20 meter, a sphere is released. It hits the ground, but then it reaches a height 5 meters. It reaches a height 5 meters. It is released from height 20 meters, but it reaches a height 5 meters after bouncing off. So what they ask is impulse caused on the ground. So impulse means impulse, right? Like that is very impulsive. That occurs within a moment, only within a moment. So when does the impulse causes here? You know that this object momentarily is in contact with the ground. As it hits the ground, only at that moment there's a impulse acting on the object. So an impulse is acting upwards, an impulse is acting downwards. Those are like action and reaction impulses. But I'll only use this impulse. But you need to find these velocities. You need to find the velocity it hits the ground. So how do you find that? Let's say that velocity is u. Then you have to find the velocity that it bounces off the ground. Let's say that velocity is v. Hits the ground velocity is u at, bounces off at v. Got it? Then you need to find these velocities first. So how do you find this velocity? You need to apply a linear motion equation, right? So to find u, I'll just apply v squared u squared plus 2as from here to here. So this is actually u here. Final velocity, initial velocity is 0. Here the velocity is 0 plus 2 acceleration downwards 10, s is 20. So this is 2 times 20, 40, 40 times 400. So u is what? 400 root means 20 meters per second. So it hits the ground at 20 meters per second. Then you need to find this v. So for that as well, I'll apply the same equation, but upwards, right? From 3 to 4. From 3 to 4. So what's the final velocity here? Final velocity is 0. Here velocity is 0. Initial velocity, they say v squared. I just put v squared minus, because now the acceleration is downwards, right? So you have to put a minus. I'm applying the equation upwards. 10, height is 5 meters. So 2 times 5, 10, 10 times 10, 100. Take 100 to this side. 100 equals v squared. So v squared equals v equals 10. So the bouncing of velocity is 10 meters per second. Got it? So this is what we needed. We found these using linear motion equations. So it hits the ground at 20 meters per second and it bounces off the ground at 10 meters per second. Right? Then we need to get impulse. What they ask is impulse. So what is impulse? Impulse is change of momentum. You need to calculate the change of momentum. You can take this down. We still just find these velocities first and take that down, velocities first, and thumbs up, right, if you're taking it down. Because I cannot see you, you have to thumbs up, right, otherwise I don't know. Okay, so we just found these velocities. The velocity it hits the ground, that velocity it bounces off the ground. Then we need to find impulse. So what is impulse? Final momentum minus initial momentum. So what is the final momentum here? Just before it hits the ground and just after it hits the ground. So just after means final. So this is final, right? 10. Mass of the object is 100 gram. I'll put up 0.1 kilogram. 100 gram means 0.1 kilogram, right? Is the mass given? Oh, the mass was not given there. The mass is not given, right? So take the mass of the object as 1 kilogram. Mass should be given, right? Just take it is a 1 kilogram object, right? Fourth question. So mass is 1 kilogram. Velocities, this is final velocity after collision with the ground. So that is 10. But these are vectors, right? So you have to mention final momentum is upwards. So you have to mention the arrow. Minus, here the mass is 1 kilogram. Initial momentum, meaning just before it hits the ground. Velocity is downwards, 20. What's the direction of this initial momentum? Downwards. Okay. These are two opposite side directions. The vectors are two opposite directions, right? So what do you have to do? You have to change the direction. So when you change the direction, what happens? Plus becomes minus. Plus becomes minus, right? When you change it to the opposite direction, it becomes minus. Then there's a minus as well. Minus minus become plus. Since all the vectors are to the same direction, now you can just add. Okay. So it should be 30 kilograms per meter per second. Kilogram meters per second. 30. And the change of momentum is upwards. Okay, so whenever bounces off, you just have to add the momentums, right? Because this minus minus becomes plus there. Okay, take it down. If you have any problems, send me, right? So I can clarify further. Right, then try fifth question. Fifth question. It is a similar question. You can try that. Fifth one. First draw is sketch, right? Then try. Those who did the question, send me the answer. So mass of the object 0.1 kilogram, right? 100 grams. Its velocity is increased from 5 meters per second to 25 meters per second. So I have to find the impulse. Impulse that caused this change. Please send me the answer. Right, let's see. So the mass is 0.1. Velocity, this is final velocity, right? 25. Direction is important. This direction. Minus mu. Mass is 0.1. Velocity 5. This is the initial velocity. So initial moment. Since these two are to the same direction, you can just simplify the numbers. So it is so 0.1 times 25 means 2.5. This is 5 times 0.5, so it is 0.5. 2.5 minus 0.5, that is 2 kilograms per kilogram meters per second. Another unit for that is Newton seconds, right? Newton seconds and kilograms meter per second, they are same, right? So what's the answer there? Fifth one, yeah, correct. Fifth answer, right? Then try sixth question. You can find answer using Newton laws F equals ma as well, but use this equation, right? This equation, Ft equals mv minus mu. Use this one. You can apply F equals ma as well, right? But use that one. Draw a sketch. These are simple questions, but drawing this sketch makes it easy, right? 3 Newton is applied opposite. And this lasts for 4 seconds. Last for 4 seconds. This 3 Newton is lasting for 4 seconds. Let's say velocity, final velocity is v. Initial velocity 5, final velocity, let's say v. You have to be careful about the directions, right? These are vectors. In order to get the correct answer, you have to be careful of the directions as well. If you got it, send me the answer, right? Right. So this equation I'm going to use. I'll say this direction, I'm taking this direction to be the positive direction. Okay? This direction to be the positive direction. If this is the positive direction, any vector to opposite direction is negative, right? You have to substitute those vectors as negative vectors. If anything is to the opposite side, I have defined this to be the positive direction. Right. Here, what's the direction of force? Direction of force is opposite direction, right? So you have to substitute as minus 3. Okay? Minus 3. Times time. Time is given as 4 seconds. Then this is equal to mass is 2 kilogram. Final velocity, I'll just put that as v to this side. So it is a positive vector. Minus mass is 2, initial velocity 5. Initial velocity 5, that also to the positive direction. So this is a positive vector. Okay. We'll just simplify this. Minus 12 equals 2v minus 10. Then this minus 10 comes to the other side, becomes plus 10. Minus 12 equals 2v. So this is minus 2 equals 2v. So v is equal to minus 1. What does this mean? We got a minus value here. So when you get a minus value, what does it mean? I have marked the velocity of this one. I don't know before solving that, right? I have marked velocity of this to be to this direction. Minus means that is wrong. Direction is wrong. It should be to the opposite direction. So to this direction minus 1, but to another direction you can make it plus. What does this mean? The object has, due to this force, object has been moving to this side, but velocity becomes 0 and it has turned back. Before solving we don't know, right? So due to this 3 Newton, object has moved to this direction. Decelerating, it moves to this direction, but it turns back. And it will gain a velocity again 1 meters per second to this direction. Here the velocity becomes 0. Okay, so after 4 seconds the velocity is 1 meters per second. Okay, take it down. And if you have taken it down, thumbs up, right? So the answer is what? 2 left. Fifth one is the answer. Fifth one is the answer. Thumbs up, right? If you've taken it down. Right. Now, all these 6 questions I have discussed. For all those questions, f is a constant, right? Got it? So whenever the f is constant, you can just multiply force by time in order to find the impulse or the change of momentum. But when f changes, so after this, forces are changing, right? Forces are changing. So if forces are changing, you cannot just multiply force by time because this f changes, right? So in that case, you are given graphs to show the variation of force. To show the variation of force. Okay? So to find the impulse, you need to refer that graph and find the area of that graph, find the impulse, and that impulse is equal to mv minus mu. So this I becomes area of the graph. Area of the graph. Okay? You can substitute area of the graph here, then you can find initial velocities, final velocities, those stuff. Okay? Okay, try seventh question. So we have this 5 kilogram, and the force applied on the 5 kilogram. So initially the object is at rest, right? If they haven't given that, object is at rest initially. Then it gains a velocity. Let's say it gains a velocity v. Initially it is at rest. They haven't given that, but if it is given, not given, you can take it like that. Initially the object is at rest, then it gains a velocity v. What's the difference? This force is not a constant force. That variation is shown by the graph. So in order to find the impulse, you can find area of the graph. Then this impulse is equal to mv minus mu, change of momentum. Final momentum minus initial momentum. So if someone found the area of the graph, send me the answer, right? You have to find the area. You have to actually separate the graph into few pieces. So this is like a triangle, right? Not a triangle. This small part is a triangle. So the area is 1 over 2, 5 times 2. So the area of this part is 5. Get it? Half 5 times 2. Then you have a trapezium. How do we find the area of a trapezium? Length of parallel sides. 5 plus 15. 5 plus 15 divided by 2 multiplied by this length. 4 minus 2, this length is 2. 2 cancels off. 5 plus 5, 15. 5 plus 5, 20. So this area is 20. Okay. Then we have a rectangle. This length is 4. 8 minus 4, so it is 4. 4 times 15. 4 times 15 is 120, right? So 15 times 2. Okay, let's see. This is 120. Then this, we have another triangle. This is 4. 4 times 15. 4 times 15. This is 4. This is 15 divided by 2. 30. So we have here, then just add all these. Okay. 150, 120, 30, 150 plus 20, 170 plus 5, 175. Oh, 15, 175, right? Isn't that? If there's a mistake, tell me. So the area of graph is 175. That is what I got. Then this initial velocity is 0. Initial velocity is 0. So this term becomes 0. Mass is what? Mass is 5 kilogram. 5 kilogram times V. That is equal to 175. For the rectangle, 50. Sorry. Yeah. Correct. For the rectangle, it is 15 times 4. 15 times 4 means 60, right? Not 120. It is 60. Okay. So now add these 90 plus 20, 100, 110, 100 plus 115. Yeah. Okay, 115. Yeah. Okay, now divide both sides by 5 in order to find 23 meters per second. 23 meters per second. So the answer is second one, right? Got it? Those who didn't got it, just take it down. Thumbs up, right, if you all understood. Right. Then try 8th question. Next one. So 2 kilogram mass is given. A force F. The variation shown by the graph. It is constant for a while, but it changes its direction, right? Direction of the force. So what they ask is speed. So mv minus mu is equal to area. So what's the area here? 4 times 4, that is 16. Here the area is 2 times 2, 4. But this is a negative area. That's what you have to understand, right? Minus 2 times 2. Okay. So the net area should be 16 minus 4. Then that is equal to, for this one as well, initially at rest. So this term becomes 0, right? Mass is 2 times V. So 2V is equal to 16 minus 4, that is 12. Then V is equal to 6 meters per second. Take it down if someone didn't get it. So the answer is 5th one for that. Got that right? If you've taken this down, thumbs up. Answer for that, 5th one. Sorry, it's not 5th one, the 3rd one, right? 6 meters per second, not 3 meters per second. Yeah, 3rd one is the answer, okay? Velocity is 6 meters per second, so the 3rd one is the answer. Right. Then try 9th question, next one. Try the 9th question. You can draw a sketch first, then try that, right? It should be cricket bat, right? Not cricket player. Doesn't matter which one hits, but then it bounces off at V. So what they ask is this V. Directions are important, right? In order to get the correct answer, direction, you have to be careful. Someone send me what's the area of the graph. So area gives us the change of momentum. So what's the area? Height 13,500. This is 0.001 divided by 2. That's the area of the triangle. Okay, let's see. So 0.001 means 1000, right? You have divided by 1000, so this becomes 13.5, isn't that? 0.001. So this is 13.5, right? 13.5 divided by 2. Not 135. Not 135. Okay. Divided by 2. So this becomes 6.75. So that's the area. 6.75 Newton seconds. That's the impulse caused due to the bat. Okay, right? 6 point, right? Not 67.5. Then think about this one. MV minus MU equals area. Area is 6.75. Now the directions are important, right? But you can actually do that at once, because this is bouncing off. We know that when you like take the difference, these two adds up, right? Minus minus adds up. So I'll just directly write that. So the mass is 0.1, velocity is v plus 0.1 times 20. So this is equal to 6.75. Zero 0.1 v equals, this is 2. 2 goes to the other side, 6.75 minus 2, 4.75, 0.1 v. Multiply both sides by 10. So this becomes v. This becomes 47.5. Is there answer like that? 47.5. I think there's a, I don't know the other side. Sorry. The mass is 0.15, right? Sorry. Mass is not 0.1, it is 0.15. Mass is 0.15, right? Okay, 0.15 v plus 0.15 times 20, 1.5 times 2, 3 equals 6.75. 3 goes to the other side, then becomes minus 3, then this is 3.75, 0.15 v. So v is equal to 3.75 divided by 0.15. So that is 375 divided by 15. So 37 has 2 15s. 7 is remaining, 75 has 5 15s. So the velocity is 25 meters per second. Yeah, 25 meters per second. I have taken the mass wrong. So the mass should be 0.15 kilogram. So the velocity is 25 meters per second. So it hits the bat. It hits the bat at 20, but bounces off at 25 meters per second. So he's pushing, right? Yeah, second one, right? Second answer. Got it? Second answer, right? Okay. Okay, so that is, I think now you are somewhat familiar with. So we discussed those three equations, right? I equals Ft, I equals Mv minus Mu. I equals Mv minus Mu, that is always valid, but I equals Ft only can be used if force is constant. If force is not constant, the variation of the force is given in a graph. Then take the area of the graph. That area of the graph is going to be equal to change of momentum, which is Mv minus Mu. So that's all you have to do, right? The force is actually unbalanced force. Capital F is unbalanced force. You know that, right? Right. There are some few more complicated questions. I mean, past paper questions. Some of the questions, right? I'll be posting those on the YouTube channel. I'll be sending the links on those, right? Those past paper questions later. Right. So that's about impulse. I think now you have somewhat of a understanding of impulse. Then write the topic linear momentum conservation law. Linear momentum conservation law. Linear momentum conservation law. So this law is really important, right? But this is a simple law, but many don't clearly understand what it means. Okay. Write down. If an unbalanced force if an unbalanced force is not acting unbalanced force is not acting on a system slash object momentum of it remains the same. Okay, so that is like very true, right? That is simple and very true, but many don't understand when it comes to problem solving. So this is what it means. Same equation, right? What it means is if there's no unbalanced force, meaning unbalanced force is zero. Without an unbalanced force, there cannot be a change of momentum. If there is no unbalanced force, there cannot be a change of momentum. So change of momentum is zero. That's what it means, right? So without an force, you cannot change the momentum of a system actually. That system part is what many don't understand, right? Okay, let's try to apply this to a collision. So let's say mass m1 has a velocity v1 and mass m2 has a velocity v2. v1 velocity is higher, right? So it collides here. At this moment it collides. So what happens when colliding? Action force m2 mass makes a force F to this side, and the reaction force also is opposite and equal, right? This force is created by m2 on m1. So this force is by m2 on m1. So how do you find the reaction force? Reaction force is by m1 on m2. So that is how action forces work, right? So as they collide, for any collision, action reaction forces, not only collisions, explosion, all those stuff, action reaction forces are same and opposite in direction, equal in magnitude, opposite in direction. Okay, now the collision happens. Then let's say they again separate and they have different velocities. Let's say v3 and v4. So I'm applying to the system, whole system, right? When you consider the whole system, what happens? This F and this F cancels off. These two cancels off. These are internal forces. So there's no force acted on the system due to the collision. The force applied on the system, when you consider both, force applied is zero because these forces cancels off. Okay. But if you consider one object, then there's a force acting on that object. But here I'm applying the equation to the whole system, right? For both m1 and m2. So this force and this force cancels off. What does it mean? momentum before collision cannot be changed. Momentum before collision is equal to momentum after collision, because due to the collision there is no external force acting. These forces cancels off. So how can you write that? So what is the before momentum? So I define a positive direction, right? Anything to this direction is positive. So initially m1 v1 plus m2 v2 is equal to after collision momentum. That is equal, right? m1 v3 plus m2 v4. So this is just a one example, right? I think everyone understood that. Take it down. Thumbs up, right? If you written down, right. So that is a one case when they collide. So you have seen for explosions as well, you apply that, right? So let's say there's a bomb here at rest. This is before explosion. So when they explode, what happens? Again, action and reaction forces are acting on each part when exploded, right? So when you take the whole system, momentum cannot change. So if it was at rest initially, initial momentum is 0. Let's say they start moving to opposite side at v1 and v2. Then after explosion, what is the momentum? Let's say this is m1, this is m2. m1 v1 to this side, but this is to the opposite side, m2 v2. So before momentum 0, after also momentum should be 0. That's why I put an equal sign there, because action reaction forces are equal and opposite direction. So for explosions as well, you can apply momentum conservation law, right? Then write types of collisions. I'll briefly explain this, right? Write the topic types of collisions. Write down first one, perfectly elastic. Then put an arrow in front of that. Then write Ke, means kinetic energy. Kinetic energy also is conserved. So for perfectly elastic collisions, you can apply initial kinetic energy of the system is equal to final kinetic energy of the system. So that is perfectly elastic, right? You can apply that. Then the another collision type is what? Inelastic. Inelastic means partial, write down, Ke loss. Kinetic energy of the system partially loses due to the collisions, right? Collisions or explosions. So that type of collision is called inelastic collision. Partial kinetic energy loss. Then the third one, perfectly inelastic. So for a perfect inelastic case, we have the maximum kinetic energy loss. Okay, all the time kinetic energy does not become 0, right? But we have the maximum kinetic energy loss for perfectly inelastic collisions. So what are the examples? Just take it down first. Right. So what is an example for perfectly inelastic collision? You throw an object towards a wall, and the object hits the wall and attached to the wall. So that is a one example. So the total kinetic energy becomes 0 there. Another example is, I think you have seen in the questions, Let's say one object moves to here and objects attach and move with a one velocity. After the collision, object attaches but is still moving. So those types of collisions also is perfectly inelastic, right? So in those cases, we have the maximum kinetic energy loss, right? So you have to clearly understand those three types of collisions. Those are the collisions in the syllabus. So whenever you see a question, you have to have an idea what kind of collision that is, right? So if the objects attached after collision, that is perfectly inelastic. Part of the kinetic energy loses, that is inelastic, just inelastic. Perfectly elastic means there's no kinetic energy loss due to collision. Kinetic energy loss is zero, right? Right. Then try 10th question. Draw a sketch, right? It's better to draw a sketch. Try 10th. So this is before collision. After collision, bullet is stuck. Then both have one velocity. Stuck. So this is a perfectly inelastic collision, right? The velocities are not given. First draw the sketch, we'll figure the velocity. Let's say the velocity of the bullet is 90 meters per second. Take it as 90 meters per second, right? Take the velocity of the bullet as 90 meters per second. It is not given. Right. So this is the system. What's the initial momentum? 0.1 times 90 plus this is at rest. So 0 for this one equals, now bullet is inside, right? So they both move at the constant same velocity. So velocity is v. So 1.4 plus 0.1. I just took v out. So 1.5v equals 0.1 times 90 means 9, right? 9. So this 1.5, you can write this as a fraction. 3 over 2 is 1.5, right? Then divide both sides by 3. Cross multiply 6 meters per second. Correct? So the whole system gets a 6 meters per second. Answer is first one. If you taken it down, thumbs up. And have a problem, send me. Right. Then try 11th one. You have to draw, that is about an explosion, right? You have to draw before explosion sketch and after explosion sketch, right? Try that. First draw the sketch. So the large part, this is before explosion. It has a velocity, right? Before explosion, it has a velocity. After explosion, large part gets a v over 2 to the same direction. That's what they say. Then what they ask is, what is the velocity of small part? We don't know actually the direction as well, right? So I'll just put this direction. If we get a direction wrong, we'll get a negative answer, meaning that direction should be opposite. Okay. 2v. Okay, let's see. So momentum initially. What is the momentum? Before explosion momentum, 3 times velocity. Positive direction, this direction I'm taking as positive. Equals after 1 kilogram times velocity plus 2 kilograms times v over 2. Okay. Then 3v equals u plus 2 cancels off, this becomes v. Take v to the other side. 3v minus v is 2v. We got a positive answer. What does it mean? The direction we taken is correct. That's what it means, right? So this gains a 2v velocity, this gains a v over 2 velocity, right? So the momentums at both cases same. Yeah, the correct answer is 2v. Fourth one, okay, thumbs up if you've taken it down. Then still we don't know what kind of collision this is, right? You have to actually calculate kinetic energies before and after. This is not explosion, sorry, collision, so you cannot define types of collisions here. This is explosion, right? Then try 12th one. Draw a sketch, okay? That's better. If you solve, send me the answer, okay? So 0.06 should be here, right? They are moving to the same direction, that's what they say. So after the collision they stuck, meaning this is an inelastic collision. If someone got the answer, send me, right? You have to find V. Okay, so what is the before collision? Positive direction. 0.06 times 12 plus 0.05 times 10 equals sum of the masses is addition of the masses. Now they are a compound object, right? So I'm adding the masses, so it is 0.11. Total mass 0.11 kilogram times velocity, right? Then just forget about decimals, right? Some students struggle with doing a calculation like this, right? Forget about decimals. Just multiply 12 by 6. 12 by 6 means 36, 72, right? It has 2 decimals. Then put the decimals. So put 2 decimals, 0.72. Then again here 0.01 times 10 means just skip a 1 decimal to this side. 0.5 equals 0.11 V. So this is 0.5 plus 0.72 2 2 2 2 1. 0.11 V. Are we getting an answer there? So 100, just multiply both sides by 100 to, yeah, like, so 121 is 11, right? Yeah, we have to get an approximate answer there. So the answer should be 11 meters per second. 121 is 11 squared, right? You can get a approximate answer, so the answer should be fourth one. Yeah, answer should be fourth one, right? Take it down, and if you have taken down, thumbs up. Then try 13. Okay, so this is the sketch. Now they have given these in momentums, right? So these are true trolleys, opposite direction, then the momentum of this one here, momentum of this one, this one. After collision, they move to opposite directions to their initial directions, meaning if it moves to this direction, it moves to other direction. To this direction, opposite direction. Okay. So these trolleys are X and Y. So for the trolley X, the momentum is given as 3 to this side. So what they ask is momentum of trolley Y. Again, just apply, this is easier, right? This is not hard, this is easier. Again, just apply momentum conservation. Let's say to this side. To this side, momentum 32. To other side, 14 minus, right? Equals this momentum. To this side, 3, but it is minus 3 because opposite direction. P plus size. Then you just have to find P. That's all. 20. Okay, let's see. 32 minus 14. 8. 18. 18 minus 3 becomes plus 3. Yeah. So momentum is 21 Newton seconds. Correct. 21 Newton seconds. Fourth one is the answer. Okay, then try 14. So they say this is elastic, perfectly elastic, right? Perfectly elastic. What does it mean? So you can apply, so after collision, let's say they get v1 and v2 velocities. Okay. You can apply momentum conservation. So if you apply momentum conservation, what do you get? Mu, that is the total momentum, equals mv1 plus mv2. Okay. So besides this, you can apply kinetic energy equations as well, because perfectly elastic. So what is that? Half mu squared equals half mv1 squared plus half mv2 squared. In order to find v1 and v2, you have to simplify these equations. You know that simplifying this is not easy, right? Like, it is easy for essay question, but for a MCQ question, simplifying these two is not easy. Actually, you can simplify, right? Mass cancels off, v1 plus v2 equals u. So in order to find v1, you just have to substitute, and you can actually, then you get a quadratic equation. Using the quadratic equation, you can find v1 and v2. That is how you simplify that. But that is hard, right? At many times in the exam, they have checked this one. So here what happens is, this is the what happens, right? For a perfectly elastic collision, whenever the collision happens, so this is at rest, this is moving at u. After the collision, what happens? They change their velocities. Always that happens, right? For perfectly elastic collisions. So you have to know that, remember that. So you can save so much time. When they collide, they change their velocity. So v1 becomes what? v1 becomes 0. This becomes u. See that? They change their velocities. This stops, then this gets a u. You can simplify this and find that, right? So that's what happens for perfectly elastic collisions, right? Okay, take it down. Velocities change always, but that is only for perfectly elastic collision. So what's the answer? What should be the answer? First one, right? After collision, this velocity becomes 0, other velocity becomes u. Correct? So the answer is first one. Right. Then try 17th question. 17th. Draw a sketch. Draw a sketch. In the PDF, those details are given, right? In the PDF. You can check those. Okay, so this is before collision, before explosion. This is after explosion. Okay. Carefully listen to this, right? This is before explosion, this is after explosion. So now there are different directions, right? Different directions. You can consider to a one direction for a one time. Let's say you are considering to this direction. So to this direction, momentum should be conserved. So what is the initial momentum? Initial momentum to this direction is 0. Then for this whole system, to this direction, momentum is mv to this direction. For this object, we don't know the velocity. So I am making it a v1. I am writing the velocity of this object, 2m, as v1 and v2. Two normal components, v1 and v2. Okay. Okay, so what is the... now to this direction mv, this is minus, right? Minus 2m v1. Take this to the other side. 2m v1 equals mv. Mass cancels off, then v1 is equal to v over 2. Right? Then we need to find v2. To find v2, you can apply equation to this direction. Initial momentum is 0. This is at rest. final momentum of the system. So to upwards it is mv, downwards minus 2mv2. So 2mv2 equals mv. So v2 is equal to v over 2. So v2 also is v over 2. Okay, now we found the velocity values. Actually, this object moves to a resultant direction, right? This is v over 2. This is v over 2. Moves to a, then you can find the resultant velocity. What's the resultant velocity? Square of each velocity is, take the root of that. So what is that? V over, you can take v over 2 squared out, it becomes v over 2. Inside it becomes root 2. So v root 2 divided by 2, that is v over root 2. So that is v1. Okay, right. What they ask is total kinetic energy released. Kinetic energy released. So you have to get the change of kinetic energy. Change of kinetic energy. So initially bomb is at rest, so kinetic energy is 0. Then you just have to calculate the total kinetic energy here. So that is going to be the kinetic energy released. So let's find that half this mass mv squared plus half another mass mv squared plus half another mass 2m. It has a velocity v over root 2. So v squared over 2. Then simplify this. Half mv squared mv squared plus 2 cancels off mv squared over 2. So 3 mv squared over 2 minus 0, right? Minus 0. Initial kinetic energy is 0. So the answer should be second one. Answer should be second one, right? If someone has an issue, send me. Okay, if you've taken it down, thumbs up. I think everyone understood that. Okay. Then there are other questions. There are like five more questions, right? You will be able to manage this, and if you have any problems, send me a message on that. Further, I'll be posting on the YouTube channel on exam questions, right? So you'll be able to practice those as well. So I think now you have a main understanding, like a basic understanding of what impulse is, what momentum is, what momentum conservation law is, right? So you have to keep doing questions in order to keep this knowledge fresh, right? Okay. Right. So on the next class, we'll be doing work and energy. So that is a very important unit, right? Work and energy. On next class means on this Thursday. On this Thursday, I'm doing work and energy, right? Okay. So participate in that. And if you have any problems, send me a message later, right? Okay, right. Then good night. Good night, everyone.